Anessa and Courtney's free response question. A population of proliferating pandas is growing logistically with a carrying capacity of 8,000. The population started at 500 and after 2 months had grown to 800. So for part A, we want to state the logistic differential equation that would be used for this problem and prove that the equation can equal this equation. For part B, we want to integrate this equation and solve so that p over m minus p equals ce to the kt. And given this equation, find the logistic equation from p over m minus p equals ce to the kt. For part D, we want to determine the population after 8 months. So for part A, we want to state the logistic differential equation that would be used for this problem, and we want to prove that the equation can equal this equation right here. So the logistic differential equation is this equation, and it's basically a given. K is the proportionality constant, m is the carrying capacity, dp over dt is the rate, and p is the number of individuals in a population. So this equation incorporates all the assumptions given and is used for modeling population growth under limited resources. So we're going to take p times 1 minus p over m and bring it down, and then we're going to take dt and bring it up here. And then we're going to find a common denominator here. We're going to take out that common denominator and then bring it up here. And we do this because we want to get this original equation into a form where we can use partial fraction decomposition. And by using this, we can set our original equation to look like this equation. So we're going to split this up. We have the denominators p and m minus p. And then we're going to multiply a over p by m minus p over m minus p. We're going to multiply this over times p over p, and we get this. It's because we set the numerators equal to each other because the denominators are all the same. And by making p equal 0, we can zero this term out, and we get that a equals 1. And by letting p equal m, we can zero this term out, or our a term out, and then we get that b equals 1. And so we put b equals 1, we put a equals 1 back into this equation, and we find that our original equation, which we transformed from this into this, by using partial fraction decomposition, we changed this into the form we wanted, this.
Okay, so for part B, it asks you to integrate the equation 1 over p plus 1 over m minus p dp equals k dt, which is what you found in part A. So to integrate that, you take the integral of 1 over p and the integral of 1 over m minus p and also the integral of k. You know that the integral of 1 over p is the same as the integral of 1 over x, so that's just going to be natural log of p like it would be natural log of x. For 1 over m minus p, let u equal m minus p. So that's du over negative 1 equals dp, and you plug that back into the equation. It's negative 1 over u, same as negative natural log of u, and when you put m minus p back into the equation, it's negative natural log of m minus p. And the integral of k is a constant, so it would be kt, and don't forget to add your c's when you integrate. So there's going to be c1 and there's going to be c2. So now that you've integrated, you have natural log of p minus natural log of m minus p plus c1 equals kt plus c2. When you subtract a natural log from a natural log, you're able to divide them, so it'll be natural log of p over m minus p and equals kt plus c3. Now that c3 came from subtracting c2 minus c1. Since you don't know what they are, you can do that. The next part, you want to solve and simplify this equation. So you're going to take everything, put the e in, and make everything an exponent of e. And this takes away this natural log right here. So that goes away. So it's p over m minus p, and then e to the kt plus c3 is the same as e to the kt times e to the c3. So now that you have that, you're going to e to the c3 can be written as c4, because you don't know what the c is, so it can just become a constant number, and so it's going to be p over m minus p equals c4 times e to the kt. And you can just let c4 equals c just to make it look prettier, and it would be the same as p over m minus p equals c e to the kt, which is what the part B was asking you for. So you've solved for p over m minus p equals c e to the kt from your original equation. Okay, for part C, it asks you to find the logistic equation from the equation that you had just solved for in part B. So you have p over m minus p equals c e to the kt. What you want to get is p by itself, so you need to multiply the denominator of m minus p on both sides so that you can get the top p by itself. So p equals mce to the kt minus pce to the kt. You have another p now on your right side, so you need to get rid of that p also. So bring that over to the left side, you get p plus pce to the kt equals mce to the kt. Isolate this p by taking it out, and it's p times 1 plus ce to the kt equals mce to the kt. Now you can get rid of the 1 plus ce to the kt on the left side by dividing, and you get p equals mce to the kt over 1 plus ce to the kt. You can multiply this equation by 1 over ce to kt over 1 over ce to the kt. That is the same as 1 over 1, so pretty much you're multiplying by 1, which will keep the equation the same, but it can get rid of the ce to the kt on the top by doing this, because the 1 over ce to the kt on the top of this equation can cancel out with this. So then you are left with 1 over ce to the kt. And this 1 over ce to the kt is multiplied by the 1 here, so you have m over 1 times 1 over ce to the kt, and this ce to the kt over the ce to the kt. So simplify that, c to the kt over c over to the kt is the same as 1, so it's p equals m over 1 over ce to the kt plus 1. You can also take the e and put that on the top of this equation, because e to the kt is the same, 1 over e to the kt is the same as e to the negative kt, so you can see that here. They said that c equals p0 over m minus p0, so that's the same as, since we're looking at 1 over c right here, let's do 1 over c equals m minus p0 over p0. Okay, we can let 1 over c equal a to make it just flow better, and that's what they just want. They just want an equation that you can work with. So p equals m over a e to the kt plus 1. So you had substituted 1 over c with a, which is right here, and you kept everything else the same. So now you have your logistic equation, which you can use later in part D. Alright, for part D, it asks you to find the population after 8 months of the pandas. So you're given, at the very beginning, a carrying capacity of 8,000, and then you know that at time 0 or 0 months it started off with 500 pandas, and after 2 months there were 800. So remember when they said c equals p0 over m minus p0? Alright, this is where we're going to use it. So remember that we did 1 over c equals m minus p0 over p0, and we let 1 over c equals a. So here's a, and so we plug in the carrying capacity m, so that's 8,000, minus 500, which is the population size at time 0, which is p0, and you get 7,500 over 500 equals 15. So that's our c now. So we're going to plug that into our equation that we had in part C. pt equals 8,000, 15e over 15e to negative kt plus 1. So now we want to solve for k, so we can figure out what the population is after 8 months. Our second piece of information gives us that at month 2, the population size was 800, so we're going to plug that into the equation. So 800 equals 8,000 over 15e to the negative k2 plus 1. Divide by 800, and it simplifies out to 1 equals 10 over 15e to the negative k2 plus 1. And if you were to take the denominator and multiply it on both sides, you would get 15e to the negative k2 plus 1 equals 10. And we're going to simplify that by subtracting a 1 from each side. 15e to the negative k2 equals 9. And divide by 15, as you can see here, simplifies out to e to the negative k2 equals 3/5. And then you're going to take the natural log of each side so you can get rid of that e. And you get negative k2 equals natural log of 3/5. Divide by negative 2 to get k by itself, and you get k equals negative natural log of 3/5 all over 2. So you plug that k back into this equation right here, and you get this, or as it simplifies out, the negative with the negative becomes natural log of 3/5 over 2t. Now this is where you're going to plug in your 8 months for your t to find the population at 8 months. So you plug that in, and the natural log of 3/5 over 2 times 8 simplifies to be 4 natural log of 3/5. So you can say e to the 4 natural log of 3/5 is the same as 3/5 to the 4, because the e and the natural log are going to cancel out and the 4 is going to be an exponent. And that's the same as 81 over 625. So you plug that into the equation for what you just subbed out, and it's P8 equals 8,000 over 15 times 81 over 625, all plus 1. And you simplify, and you get 8,000 over 243 over 125 plus 1. And then you further simplify, it's 8,000 over 368 over 125. And P of 8 equals 8,000 times 125 over 368, because that just switches when you put that on from the denominator to the numerator. So it's 125 over 368, and then you simplify that again, and you get 2,717 pandas, and that is your final answer.